Alright, this video is going to go in depth on another way we can kind of use knowledge about polynomials to see what their graphs are going to look like. So in the title here, I use kind of a fancy higher level math vocab here. Local maximums and minimums. All that means a local maximum or minimum. With a parabola, there's just a minimum and it's fine, or just a maximum and it's fine. But when you get crazier looking graphs like one of these, there's a couple spots where there's kind of a maximum or a minimum here. So we can't just say, oh, the maximums, because that could mean either of these. A local maximum just means one individual spot where there's a high point, or a local minimum is a spot where there's a low point. That's more stuff you'll talk about in pre-calc. I just really honestly didn't want to have, I need to give you guys the right math vocab so you know the words. But it's a lot easier to refer to these. I kind of talk about them like the bumps on a graph. That's kind of a much more common way, like everyday language way of saying it, rather than a local max or min. We're going to talk about the bumps on a graph. So if we want to figure out what degree the polynomial is going to be, we're going to count how many bumps the graph has, and we're just going to knock that number up by 1. That'll be our minimum degree. It may sound a little complicated, but it's not going to be hard to use. This rule, again, is what I just basically read out there. It's kind of important, so make sure you write that down. If we're looking at our first graph here, there's one bump on our graph. That means the smallest degree possible for this graph is 2. So it's at least degree 2. There was one bump. You have to go one higher than that. We got 2. That means this is going to be degree 2, degree 3, degree 4, degree 5, something higher, 2 or higher, basically. If we look at our second graph right here, 1, 2, 3, 4, there are 4 bumps on the graph. So this graph has to be at least degree 5. So if we saw an equation that was x to the 4th or x to the 3rd power, those would be out. We don't know exactly what it will be, but it's at least 5. So it's 5 or higher for our degree. On our last example here, we have 1, 2, 3 bumps on the graph. That means our polynomial is going to be at least degree 4. So 4, 5, 6, 7. We don't know exactly what it is. There's no way to know that for sure. But we know, for example, this couldn't be degree 2. So this is not a parabola. It's not an x squared. This one right here is at least degree 2. So we have no idea. It could be anything higher than 2 or higher. But it's obviously not like degree 1. It's not a line. So on the second slide here, I have just a couple things that I want to go through. The sort of thing I'll ask you to do on a quiz is I'll give you a picture of a graph and I'll ask for a couple things. So looking at this graph here, we're kind of summarizing the stuff from the last video in this one. We want to know if this is even or odd degree. Since it's going in different directions, one up, one down, we know that means it's odd. So the leading coefficient, we want to know if it's positive or negative. Well, the graph is going down as we go to the right, so that means it's a negative leading coefficient. Okay? The minimum possible degree that it could be, we have 1, 2 bumps on our graph, so it's at least degree 3. And this last thing here is kind of a review from a previous thing. A real 0, remember, is like the x-intercept on the graph. So this graph has 1, 2, 3 x-intercepts. So real zeros is talking about the x-intercept. And there are 3 of those as well. So the final thing in this video here, we're taking the same problem, and I just showed you why this would even be useful. It's actually really helpful when it comes to answering multiple choice questions. So they gave us 4 equations right here, and they said, which of those can match that graph that we were just looking at? Well, we know the first thing we learned is that the degree is going to be odd. If you look at these choices, this is even degree right here, so that's clearly wrong. So is this one, degree 4. 2 choices are out just by knowing the degree rule. The leading coefficient needs to be negative on this. Well, that means this choice is out because it's got a positive leading coefficient. We're already down to just 1 choice. So this is evidently the best equation for it because we knew our rules and we applied them to figure out the equation.